Oh, good morning, good morning. We are here today at Unit 1, Lesson 4. This is angle relationships. In a special case where parallel lines are cut by a transversal. What is a parallel line? Well, parallel lines are two lines that never intersect. We generally will put two little looks like greater than symbols, and we usually call one line 1 and one line 2. And what we end up having is a situation where we have these parallel lines coming through here. Let's just find something quickly to draw with. We have these parallel lines, 1, 2, going in both directions, line 1 and line 2, and all of a sudden we have a transversal line that comes across and crosses these two lines a certain way, and we call that a transversal line, and we usually call that one line T. And we have all these special angle relationships that are formed, and we're going to explore all the different angle relationships, and you're going to be able to name some congruent and supplementary. Now let's do a little notes here. Congruent is an important one. It means that they are equal. And then we have this one that says supplementary. That's a big word that means sum to 180 degrees. So two angles that add up to 180 degrees. All right, you're going to be finding missing angle measures and apply some of these angle relationships. And we're going to use some GeoGebra to do some measuring tools. So the other important big word here is perpendicular, and that's a big word. And that means that there are two lines and they intersect, and they have this little right angle, which is 90 degrees. It's always marked with a little square here that shows that it's 90 degrees. Okay, it's very important in life that you know what parallel and perpendicular are. So let's take a look at our vocabulary here. We have some big vocabulary in this unit. We have a line that intersects two or more lines. It's called the transversal. So we just looked at that. This is wrong. Let's call this one, let's make this in red. So if you want to change this in your book, it's on page 372. We're always going to call the parallel lines line 1 and line 2, and we have our parallel lines there. We have our transversal line coming across as line, we're going to call this line T. That's the T for transversal. And you can see that word here. We have some big vocabulary in here. We have what we call a linear pair. They're adjacent and they form a 180 degrees supplementary angle. 1 and 2 is an example of a linear pair. We have vertical angles. Those are opposite and they're congruent. They're opposite and congruent. So let's highlight a few of these things. Vertical angles, two lines cross, opposite and congruent, linear pair. They have to share an angle, and they add up to 180 degrees. And then we have interior angles, and we need to know what that means. When you see something that says interior, that means it's between the parallel lines. So we have interior here and interior here between the parallel lines. So that makes this outside part exterior and this part out here exterior. Okay. Alternate interior angles are going to be on alternate sides like 4 and 6 here, and they're going to make the same exact congruent, they're equal. So 3 and 5, 4 and 6 here, they are congruent. I don't see that word here, so let's just add it. Alternate interior angles are congruent. Interior, on the alternate side. When they say alternate, they mean alternate of the transversal line. On alternate sides of the transversal line. Versus same side, so that's the transversal line. 4 and 5 are on the same side. Interior, they don't look like they're equal, they aren't. They're supplementary. They add up to 180. So if they're on the same side, they sum to 180 degrees. So angle 4 plus angle 5. They're on the same side here. They would add up to 180 degrees. And then you have corresponding. These deal with same position, but on a different parallel line. So 1 and 5. Let's take a look at where 1 and 5 are. See how 1 is up and left, and 5 is up and left, but they're on different parallel lines. So corresponding angles are similar location, but on the other parallel line. We can write that for parallel. Okay. And of course, these are congruent. So that's a lot of vocabulary, but thankfully you have a second page here. Let's go to page 2 of the notes. Remember to save your notes. Save your notes, because they all get turned in for a grade at the end of the unit. Big points. These notes are also going to be available in your Google Classroom. All right, so we have page 2 of the notes. Let's turn this bad boy right here to, we turned it counterclockwise 90 degrees. Now we're looking at all these angle relationships, but we only need to focus on what the special relationships are. We're going to use special markings to look at what a linear pair is. Let's start with a red pencil or pen, and we'll look at what is a linear pair. Let's make a little arc. A linear pair is 180 degrees, because it's supplementary. They sum to 180 degrees. So this angle here, ICD, is made up of ICG and GCD, and together the two angles form a linear pair. Linear being a line, there's a pair of angles, and they form a line. So two angles that form one line, linear pair. That should make sense to you. Vertical angles are the easiest ones to find. These are just that when two lines cross, they're the angles that are formed opposite. Let's do it in yellow highlighter. This angle and this angle are vertical angles. We should actually practice how to write these. So let's do the vertical angles first. That's super easy. We have to name them with the letters I, C, B. And we use this congruent symbol. It's an equal sign with a similarity here. I, C, B, congruent to G, C, D. Like that. Now let's do our linear pair. Our linear pair was angle ICG, but it's not the same angle. You can see this one's 52.1 and this is 127.9 degrees. So we're going to add them together, GCD. When I add them together, I get 180 degrees. So it's a different statement because the linear pair are forming a 180 degree angle where the vertical angles are equal to each other. Now we have two of these that are interior. So let's look at the first situation. I'm going to switch to a blue. I'm going to switch to green. I'm going to use a green circle here to circle alternate interior angles. This key word being interior. Let's highlight interior here. I'm just going to do it in blue. Interior. This whole area, if you want to highlight it, is all interior. in between the parallel lines. We need to be given that line 1 is parallel to line 2. And if you want to pop some red arrowheads in there, that's super good. Okay, alternate interior angle. So now when we're talking about alternate, we're talking about the transversal. So here's your transversal line. And when you're traveling on the transversal line, you could either be on the same side, in this case it's below, or you could be on alternate sides. So let's take a look. We have green circle, okay? Notice, here let's travel along the transversal line. Are they on the same side of the transversal line or alternate sides? Okay, we can see that these would be on the same side, these are on the alternate side. What is their relationship? The relationship is that they are congruent. So if we need to make a little statement here, I'll use my green pencil, and I could say that angle ICB is congruent, ICB is congruent to CBF. Okay, and we just identified the same side, alternate angles. I need another color here. Okay, I'm going to use a third color. I'm going to use this purple. You can use another color. Just don't use the same color. We'll make a little square. I'm going to make a rectangle, I should say. A rectangle. And I'm going to rectangle. We're still using the same angle. So this angle has a lot of relationships right here. And now they're on the same side of the transversal. Remember, we travel on this transversal line. We're traveling on the transversal. And they're both on the same side. They're both under the transversal. So you can look at them. Are they the same angle? Yes or no? No. This is 127.9. That's 52.1. So we have to make a statement that the 127.9 plus 52.1, those add up to 180 degrees. But I want to be able to name it as with angles too. So what is that angle right there? It's angle ICB. The C is in the middle because it forms the angle. Plus, now let's do this one. Well, we have to go this way. CBA. That adds up to 180 degrees. Okay, so that's how you name the angle. And then finally we have corresponding. Corresponding is a very interesting situation. Okay, these are, like we said before, they're in similar location, but on the other, they're on different parallel lines. A good situation to look at would be, we could use the same exact angle. If we could do that one more time, we'll use the same angle one last time. If I can find one other color here. I have an orange. Let's try orange. Let's say let's use a different angle. We'll use this 52.1. Now it's left on this parallel line. It's the one that's on the left. Same parallel line, same angle. It's over here. Let's do a circle. We'll do a circle. And then we'll circle corresponding angles. And we can see now they're in similar locations, both to the left here, where the parallel lines and the transversal come in. They are exactly the same, which means that they are congruent. So let's make a statement here that GCI, angle GCI, is congruent, GCI, CBA. And that's all of the special relationships. And by knowing just that pieces of information, you can find, if you have one or two, just one angle, you can find all the missing angles like a puzzle. From that, we are going to do your rally table at some point. You're going to do rally table. These are the same lines, but they're also on a Y and an X axis, so these are exactly the same. And then your rally table instructions will be provided to you. So it'll be rally table time, and you'll have fun playing that. All right, good luck.